Hi, good morning everyone. Today I will discuss about the magnetic quantum numbers. This is the new quantum number. Already in last two classes I explained about principal quantum number and azimuthal quantum number. Now today I will explain about magnetic quantum number. Magnetic quantum number 3. See, magnetic quantum number proposed by Lande and Zeeman. It represented by letter M. Magnetic quantum number represented by letter M. M can have values of minus L to plus L, including 0. Generally, it represents spatial orientation of orbitals. Magnetic quantum number represents spatial orientation orbitals. This is the very important point. Number of orientations, spatial orientations, M is equal to 2L plus 1. Number of spatial orientation, M is equal to 2L plus 1. For example, if we take p orbital, number of spatial orientation for p orbital, M is equal to 2 into 2 plus 1, that is 3 spatial orientations possible for p orbital. Why? If L is equal to 1, that is known as p orbital. If L is equal to 1, that is known as p orbital. For p orbital, 3 spatial orientations are possible. See here, some points I will explain. Magnetic quantum number is represented by Lande and Zeeman. It is represented by letter M. M can have values minus L to plus L including 0. Minus L to plus L including 0. It represents spatial orientation of orbitals. The number of spatial orientation of orbital M is equal to 2L plus 1. If L is equal to 1, it is p orbital. M is equal to 2 into 2L plus 1 is equal to 3. Understood? Now, about take p orbital, that is L is equal to 1, it is known as p orbital. Number of spatial orientation, M is equal to 2L plus 1, that is 2 into 1 plus 1, 3. So here the number of spatial orientations are 3, that is M can have minus L, 0 plus L. What is L value? 1. Minus 1, 0 plus 1. So means P contains 3 suborbitals, that is Px, Py and Pz. Px, Py, Pz. The Px means, for example, take every orbital is x-axis and y-axis. If orbital present along with x-axis, this is known as Px. This is Px orbital. And if you take another one, see the orbital present along with y-axis, that is known as Py orbital. And take another one, it is z-axis, x-axis, y-axis. Now take on z-axis, it is known as Pz orbital. So here in Px orbital, the total electron probability along with x-axis, see, only one time it is 0 along with x-axis. So this is called one nodal plane. Every p orbital contains one nodal planes only. Then L value is 1. If number of nodal planes 1, that is L value 1. But M indicates, what is M indicates? The p orbitals are existing 3 suborbitals, that is Px, Py, Pz. Px means it is L value, M values are minus 1, 0, plus 1. So this is known as spatial orientation. See, spatial orientation means in x space the orbital arranged. Here along with y axis the orbital arranged. Here along with z axis orbital arranged. Based on this we can explain spatial orientation of orbitals. Not only this, we can take another example also, that is L is equal to 2, it is known as d orbital. L is equal to, it is known as d orbital. Means minus total number of orbitals 2 into 2L plus 1. For d orbital, M is equal to 2 into 2 plus 1 is equal to 5 orbitals. Means 5 values are possible. What are that values? Minus 2, minus 1, 0, plus 1 and plus 2. So these are 5 values, that is minus 1 to plus 2. Here in representation it can change, interchange also takes place, but 0 represented by dz square, and it is dxy, dyz and dzx, dx square minus y square. So d orbitals, 5 d orbitals are present. For if you take any d orbital, it contains 5 d orbitals, 5 spatial orientations are present. They are dxy, dyz, dzx, dx square minus y square, dz square. So all are known as equal energy orbitals, hence these are called degenerate orbitals. All energies of orbitals are equal. Then all d orbitals here degenerate orbital. 5 suborbitals are present. 5 suborbitals are called degenerate orbitals. The 5 suborbitals all are called degenerate orbitals. Degenerate orbitals means equal energy orbital. Degenerate orbitals. Degenerate orbitals means the orbitals which are having equal energies are called degenerate orbitals. dxy equal energy with dyz and dzx, dx square minus y square, dz square. Now I will write the shapes of orbitals. For example, if we take dxy, observe, we know it is x-axis and y-axis. So according to this, the dxy means the orbital present between x and y-axis, not on the axis. This is called dxy. And dyz, the orbital present between y-axis and z-axis, like this. It is known as dyz. dzx, the orbital present between z-axis and x-axis, between the z-axis and x-axis. d x square minus y square, the dx square minus y square, dx square minus y square means the orbital along with the axis, that is x-axis and y-axis. This is known as dx square minus y square. And dz square, here also, for example, take it is z-axis and it is x-axis. The two orbitals are present on z-axis only. These are known as shapes of orbitals. Here dxy, dyz, dzx, dx square minus y square, dz square. Everyone must practice that shapes also. The shapes also very important. These shapes also very important. Everyone must try the shapes also. And here some points. These all orbitals are having equal energies. These all orbitals are having equal energies. The equal energy orbitals are called degenerate orbitals. Degenerate orbitals, because if you take here, for example, take here, I will write here 3D orbital. 3D orbital. 3D orbital means it contains 5 suborbitals. 1, 2, 3, 4, 5. See, all are having equal energy means n value for 3D orbital, n value 3. For L orbital, L is equal to. See, for this 3 plus 2, 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 all are having value 5. See, all are degenerate orbitals only, equal energy orbital. If this n plus L value equal, they are known as equal energy orbital. So 5 d orbitals, it is known as one orbital is dxy. See, another orbital dyz, another orbital dzx, another orbital dx square minus y square, another orbital dz square. 5 orbitals present. All 5 orbitals are having equal energies. The equal energy orbitals are known as degenerate orbitals. So here the magnetic quantum number explains the spatial orientation of orbitals. Number of spatial orientation of orbitals explained by using only magnetic quantum number. In this magnetic quantum number, we can also explains number of nodal planes. See, number of nodal planes also explained based on magnetic quantum number. See, number of nodal planes. This is number of nodal planes is equal to generally number of nodal planes is equal to L. For p orbital, how many nodal planes are present? For p orbital, L value 1 nodal plane present. What is nodal plane? Nodal plane means, for example, if you write x-axis, for example, take px orbital. This is known as px orbital. Here, node means 0 probability of finding electron. The probability of electron where finding 0, that is called node. Nodal plane means along with x plane. If probability of electron is 0, that is called nodal plane. So here one time along with x axis. So here one time the probability of, here this is known as probability of electron. See, we have, this is known as probability of electron. So and one time the probability is 0, hence it explain in x axis, it gives some shape that is called dumbbell shape. But what the magnetic quantum number explains, if L is equal to 1 means we have m minus L, 0 plus L. Means here 3 orbitals are present, px, py, pz. So all are having only one nodal plane, px having one nodal plane, py having one nodal plane, and pz having one nodal plane. But the along with the axis, the planes also we can explain based on along with the axis. Yes. Along with the axis explained the based on the probability of electron. Okay. Now the L is equal to 1 means it is only one nodal plane present. The m can have minus 1, 0, plus 1. This is known as what? Magnetic quantum number. See, magnetic quantum number explains what? Spatial orientation of orbital. That is px, py, pz. Px, py, pz. Understood or not? So, for example, if you take number of spatial orientations for s orbital, see s orbital. For s orbital L0, then m is equal to 2l plus 1, like 2 into 0 plus 1, it is equal to 1 only. So every s orbital is only one orbital. That is known as, take for example 2s orbital, take like this. Maximum electrons present here 2 only, because only one orbital present for 2s orbital. For example, if we take 2p orbital, 2p, that is 2p orbital contains 2px, 2py, 2pz. Why? Because L value is 1 for p orbital, minus 1, 0, plus 1. Then maximum number of electrons present, 1, 2, 3, 4, 5, 6, 6 electrons. So based on magnetic quantum number, we can explain spatial orientation of orbitals. This is about magnetic quantum number. Magnetic quantum number explains the number of sub-energy levels present in orbitals, number of suborbitals present in orbitals. For example, if you take how many suborbitals present in d orbital, f orbital, how many suborbitals present in f orbital, the number of suborbitals present in f orbital, the number of suborbitals present in f orbital. For f orbital, L value is 3, then m value 2l plus 1, that is 2 into 3 plus 1 is equal to 7 suborbitals. So here f orbital contains 7 suborbitals. The total number of suborbitals present in f, 7 suborbitals. So 7 suborbitals means the total number of electrons present in f orbitals. Generally f orbital contains L is equal to 3 means minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So total orbitals, see, represent like this: 1, 2, 3, 4, 5, 6, 7. So each one 2 electrons. So total number of electrons present in f orbitals is equal to 14 electrons. That is total number of electrons. We can calculate the total number of electrons present in f orbital or p orbital or d orbital or s orbital. It is based on only number of spatial orientations. Number of spatial orientation you find by using only magnetic quantum numbers. This is about magnetic quantum numbers, and last 3 previous classes, one is principal quantum number explained, another one is azimuthal quantum number explained, this is magnetic quantum number. So these 3 quantum numbers are very important for objective in the higher class also, for IIT program, for NEET program, and to know where the electron present in atom is also very important by using only quantum numbers. Okay, thank you, practice well, goodbye, take care.